Before watching these videos, please make sure that you have already watched 2 lectures of this parabola, because this is the continuation of this of those videos. So in those videos we have discussed the various terminologies like focus, directrix, latus rectum, double ordinate, etc. And in the second video, we have discussed the various forms of a parabola. And now, see, if you consider 8t square comma 2at, this point, if you substitute in the parabola y square equals to 4ax, then this point, if you substitute in this equation will be satisfied. So, for example, LHS, if I take LHS is equals to, what is y? Y square is equals to, y is 2at whole square. This is equals to 4a square t square. And now RHS if you take, then 4ax is equals to 4ax is at square. So here 4a square t square. Therefore, this point, when we substitute in this parabola gets satisfied. Therefore, this point 80 square comma 280 is said to be the parametric point of the parabola y square equals to 4ax. And so x is equals to 80 square comma y is equals to 280 are said to be the parametric equations of this parabola. Now let us discuss the notations of this parabola. So notations. So S is y square equals to 4ax. That is y square minus 4ax is equals to 0. Okay, or y square minus 4ax. What is S1? y1 minus 2a into x plus x1. S11 is y1 square minus 4a x1. That means simply substituting the point P x1 y1 into this. The point P x1 y1, when we substitute in this, we will get y1 square minus 4a x1. Similarly, what is S22? Substituting the point px2y2 in the given parabola. This is substituting px1y1 in the given parabola. So this is obviously y2 square minus 4ax2. And what is S12? y1 y2 minus 2a into x1 plus x2. If you see S21, this is y2 y1 minus 2a into x2 plus x1. If you observe, S12 is equals to S21. And so these are the various notations of this parabola. So these notations we have also discussed in the chapter circles. Now let us discuss the position of a point in a plane with respect to a parabola. Position of a point in a plane with respect to a parabola. So, let us take the parabola y square equals to 4ax, and this is the coordinate axis. This is the coordinate axis, x dash, y dash. This being the vertex A at the origin. So let us suppose that this be M is the point on the x-axis. So which is at a distance of x1. So this is x1 comma 0. since this point M is lying on the x-axis, y coordinate is 0. So let px1 y1 px1 comma y1 be any point in a plane. So draw a perpendicular PM. Draw a perpendicular PM. Draw a perpendicular PM which PM on the principal axis x-axis and which cuts the parabola at Q. So this point is Q. That means this point is also at a distance of x1 from the origin, from the y-axis. So this is also x1. But this height, how much is this height? I don't know. So let us suppose that this to be QM. Since the point Q x1 comma QM lies on the parabola, y square equals to 4ax implies QM whole square QM whole square equals to 4a into x1. So this is equals to QM is equals to square root of 4a x1. This is 2 root of a x1. This is QM. Therefore, this QM is how much now? 2 root a x1. That is, this is equals to x1 comma 2 root of a x1. Now, so what is PM now? PM is the distance between the 2 points x1 y1 and x1 comma 0 is square root of x1 minus x1 whole square plus y1 minus 0 whole square. So that is PM is equals to, or PM square is equals to y1 square. PM is square root of, what is PM here? PM is equals to square root of x1 minus x1 whole square plus y1 minus 0 whole square. So now this is y1, so PM is equals to square root gets cancelled, so y1. So PM square is equals to y1 square. Now, what is QM here? QM is equals to 2 root of ax1. Therefore, QM square is equals to 4a square x1 square. Now, since P lies outside the parabola, this P lies outside the parabola. Therefore, obviously this MP distance is more when compared with the MQ. So PM square is greater than QM square, because this distance is more when compared to this distance, this length. So what is PM square? Y1 square is greater than 4ax1 square. From this, y1 square minus 4ax1 is greater than 0. Therefore, what is this? S11 is greater than 0. Therefore, we have arrived to a condition that S11 equals to 0 when P lies outside the circle. Now, the second condition is if P lies inside the parabola, then this PM. So if P lies inside the parabola, for example, let us see, take this P is here, then PM or like way here. So here. So PM is less than QM. PM is less square. That is y1 square minus 4x1 is less than 0. That is equals to S11 less than 0. Therefore, if P lies inside the parabola, then S11 less than 0. And the third condition is, if P lies on the parabola, that means on the circumference of the parabola. On the parabola, for example, this. So Q and M are equal. That means PM is equals to QM. PM square is equals to QM square. PM square is Y1 square is equals to QM square is 4AX1. That means Y1 square minus 4AX1 is equals to 0. Therefore, S11 is equals to 0. So these are the three conditions when the point lies outside the circle, outside the parabola, inside the parabola, on the parabola. Outside the parabola, S11 greater than 0. P lies inside the parabola, S11 less than 0. If P lies on the parabola, S11 equals to 0. Now let us start the exercise 3A. So the first problem is, find the vertex and focus of 4y square plus 12x minus 20y plus 67 equals to 0. So given parabola is 4y square plus 12x minus 20y plus 67 equals to 0. Now, this is 4y square minus 20y is equals to minus 12x minus 67. So, y terms I kept on LHS and the remaining x and constants I transposed onto the RHS another side. So this is equals to, so to make the quotient of y square 1, I'll take 4 as a common. So 4 into y square minus 5y is equals to minus 12x minus 67. Now 4 into, this is a square minus 2ab. So plus b square I want to convert this into a minus b whole square. So for this, y minus, the quotient of y is 5. Its half I will take here and I will complete the square here, minus 5 by 2 whole square, 25 by 4. So you can even check with this. See this, a minus b whole square. So a square, that is y square, plus b square, 5 by 2 whole square is 25 by 4 minus 25 by 4. So, whichever that is not there, I just balance with the plus 5 by 2 whole square minus 5 by 2 whole square. So, a square minus 2ab plus b minus 2ab. 2 into y into 5 by 2. 2 gets cancelled. So, 5 into y, 5y I am left with. This is equals to minus 12x minus 67. This is equals to 4 into 4 into y minus 5 by 2 whole square minus 4 into 4 gets cancelled. I am left with a 25 here is equals to minus 12x minus 67. This is equals to 4 into y minus 5 by 2 whole square is equals to minus 12x minus 67 plus 25. This is equals to minus 12x minus 7 minus 5 2, 6 minus 2 4. So therefore this is equals to y minus 5 by 2 whole square is equals to this 4 when I transposed onto another side. This is 1 by 4 into this. This is equals to 4 3s are 12. So minus if I keep outside itself, then this is what I'm getting. So minus of 4 3s are 12. Next 4 3s are 12. 4 okay, otherwise this is what I get. So 12x plus 42, this is equals to y minus 5 by 2 whole square is equals to minus 1 by 4 into 12. If I take common, then this is x plus 42 by 12. So 6 2s, 6 7s. This is plus 7 by 2. So 4 3s are 12. This implies y minus 5 by 2 whole square is equals to minus 3 into x minus of minus 7 by 2. So what is required is vertex and focus. First of all, this could be compared with the y minus k whole square is equals to minus 4a into x minus h. This y square equals to minus 4x parabola is there. Its vertex is at the origin. So, but here its vertex is at the h comma k. So, therefore, the vertex for this, the vertex is vertex A is equals to 0 0. But for y minus k whole square equals to minus 4a into x minus h, the vertex is A is equals to h comma k. So what is h? H is minus 7 by 2. So here minus minus same in the place of h minus 7 by 2. And what is the value of k? Minus minus, so k is equals to 5 by 2. So this is what we have to find. And not only that, focus. The focus of this y square equals to 4ax is focus of y square is equals to minus 4axb, because this y minus k whole square equals to minus 4a into x minus h could be compared with the y square equals to minus 4x. Its vertex is at the origin and its vertex is at h comma k. Here the transformation of axis has happened. Therefore, the origin 0 0 has been shifted to h comma k. And now for this, what is focus? S is equals to focus S is equals to how much? Minus a comma 0. So if the parabola do not strike to your mind, so I will facilitate this for you. So y power even symmetric about x-axis. Which x-axis? Negative x-axis. It will open in this way. So now the focus is here. So this is origin 0 0. Since this focus is lying on the negative x-axis, it would be minus a comma 0. So this is y square equals to 4ax minus 4ax curve. But here this parabola is like this. The origin is here and the shifting of origin has happened. 0 o dash is h comma k here. This is the vertex now. So therefore, with minus a comma 0, for minus a comma 0, additionally h would be added here and 0 to 0 k would be added. So minus a plus h is what we need to find. So first of all, what do I require is a. So here minus minus same, 4a equals to how much? 3. 4a equals to 3. 4a equals to 3. A equals to 3 by 4. Therefore, the focus S is equals to minus a plus h, comma, k. This is what we need to find. So minus a is 3 by 4, h value is minus 7 by 2, minus 7 by 2, and k value is 5 by 2. Therefore, this is minus 3 by 4, plus into minus minus, by 4 is the LCM. So minus 3 plus into minus minus. So 4 by 2 is 2, 2 7s are 14, comma 5 by 2. Therefore, this is minus 17 by 4, comma 5 by 2. So this is the focus. Now, find the vertex and focus of the parabola is this now. So, solution, given equation of the parabola, given equation of the parabola is x square minus 6x minus 6y plus 6 equals to 0. Now this is x square minus 6x. X terms I keep on one side and the remaining y and constant on the other side. This is equals to 6y minus 6. This is equals to, here I will complete the square for this. X square minus 6x. X minus, if here plus is there, same plus you write. If minus is there, x coefficient is what I am talking. The symbol of this x is positive, same positive you take. Negative, negative you take. Now, what is the quotient of x? 6. Half of that, 3. Complete the square. Minus, whatever you have written here, you square it. 3 square, 9. 3 square, 9. So, now the equation is balanced. X minus 3 whole square minus 9 is this only. You know how? This is x square, 3 square 9, a square plus b square, minus 2ab, 2 3s are 6x, minus 9. 9 gets cancelled. I am left with x square minus 6 only. So this is equals to 6y minus 6. This is equals to x minus 3 whole square. This is equals to 6y minus 6 plus 9. 6y, 9 minus 6 is 3. This is equals to x minus 3 whole square. X minus 3 whole square is equals to, take 6 in common here, then 5 plus 3 by 6. This is 1 by 2. So this can be written as x minus 3 whole square is equals to 6 into y minus of minus half we can write. This plus is minus of minus. Therefore, this can be compared with x minus h whole square is equals to 4a into y minus k. So this is the parabola. X minus h whole square is equals to 4a into y minus k. This is the parabola. Having vertex at h comma k and whose axis is parallel to this x square equals to 4ay. This can be compared with this x power even symmetric about y axis. Here parallel to y axis. So which y axis? Positive y axis. To positive y axis. For this, you no need to remember about the features of this. Instead, so what is the x square equals to 4ay? So what are the specifications for x square equals to 4ay? So actually the Curve of this is x power even symmetric about y axis. This is that. And vertex S is here, which is 0 comma A. And here the vertex is A, 0, 0. But now for this parabola, this is the vertex 0, 0. Therefore, this is no more a 0, 0 because shifting of origin has happened here. This is h comma k. That is why this is no more 0 comma a. 0 plus h, a plus k. So this is h comma a plus k. Okay. Now, what is here? 4a. 4a equals to 6. From this, what is a? 6 by 4, which is 3 by 2. Therefore, now, what is the focus? Focus is, first vertex is A, 0, 0, h comma k. What is h here? In the place of h, you may see 3 here, comma. In the place of k, minus half is here. So 3 comma minus 1 by 2 is the vertex. And focus is, focus S is equals to h comma a plus k. What is h? 3 comma a value is 3 by 2 plus k value is minus 1 by 2. So this is 3 comma 3 minus 1, 2 by 2, which is 1. Therefore, vertex is 3 comma minus half and focus is 3 comma 1. Find the equations of axis and directrix of the parabola. So, given equation is y square plus 6y minus 2x plus 5 equals to 0. This implies y square plus 6y, I will keep on LHS and the remaining terms on the other side. Now, so I have to express this in a plus b whole square. Here y has the symbol plus, therefore it is a plus b whole square. Had it been minus, it would have been a minus b whole square. Okay. Now, this is y plus, the quotient of y is 6, it's half. 3, complete the square, minus 3 square 9. So, y square plus 3 square plus 2 3s are 6y. So, y square, 3 square 9, 9 9 gets cancelled, 2 3s are 6y is this, is equals to 2x minus 5. So, this is equals to y plus 3 whole square is equals to 2x minus 5 plus 9 plus 4. This is equals to y minus of minus 3 whole square is equals to 2 into x plus 2, x minus of minus 2. So this is of the form, y minus k whole square is equals to 4a into x minus h. So here 4a is equals to 2. Therefore, a is equals to 2 by 4, which is 1 by 2. So this is the parabola. This is the parabola having vertex at h comma k and axis is parallel to, see here y power even symmetric about x axis. Here y minus k whole square axis is along parallel to x axis. Axis is parallel to x-axis. So you no need to remember the features of this y minus k whole square is equals to 4 into x minus h. So this parabola, what is the standard form of the parabola with compared to this? Y square equals to 4ax. So for this, y power even symmetric about x-axis. That too, x has positive here, therefore positive x-axis, and therefore the axis here is x-axis. X-axis is y is equals to 0. But here the situation is something like this. Okay, the vertex is no more at the origin. It is other than 0, 0, which is this is h comma k, and this is the origin here. Now, what do we require to find axis? Here, y equals to 0, but here this is parallel to x-axis. So this is y is equals to k. Y is equals to k. So therefore, equation of axis or principal axis is y is equals to k. K here is minus 3. Because if you compare here, h comma k is equals to how much? H is minus 2, k is minus 3. So this is the vortex actually, which is not asked, but this is the vertex minus 2 comma minus 3. So therefore, equation of axis is y plus 3 equals to 0. And equation of directrix. For this, what is the equation of the directrix? This. Okay. So this is x is equals to. So this is a comma 0. Actually, if it is not at the origin, for y square equals to 4x, a comma 0. This is minus a comma 0. So this line is parallel to which axis? Y axis. Any line which is parallel to y axis, x equals to minus a. But here, the origin, but here, this is 0 comma 0 actually. But here, the parabola is this. Because this is not y square equals to 4x, it is y minus k whole square is equals to 4a into x minus h. Therefore, the origin here is shifted to here. Therefore, it is no more 0, 0. This is h comma k. H comma k. This is h comma k. And therefore, this focus will be a comma 0 actually. This is a plus h comma k. And this is how much? Minus a plus h comma k. Now therefore this is x is equals to minus a plus h. This is what we are looking for. Therefore, equation of the directrix is actually x is equals to minus a. But here hence since the transformation of axis has happened, so without changing the actual direction of the coordinate axis, this is my capital X now. So small x is equals to capital X plus h. So this is minus a plus h. So this is minus a is 1 by 2, h is minus 2. So this is equals to minus 5 by 2. X equals to, this is equals to 2x plus 5 is equals to 0. Find the equation of the parabola whose focus is s 1 comma minus 7 and vertex a is 1 comma minus 2. Here, first of all, before this, I just wanted to tell you something. The comparative method, that is, for example, this is the parabola if you take. This parabola if you take. So, this parabola is symmetric about y-axis, that to positive y-axis. The parabola symmetric about y-axis x power even. So this is x square equals to 4ay. So for this parabola, this is the vertex, this is the focus. So the vertex is 0, 0 and the focus is 0, comma a. Why? Because this point lies on the y-axis, x coordinate is 0. Here 0, 0. If x coordinates are equal, it is, if x coordinates are equal, the parabola is symmetric about y-axis. If the parabola is symmetric about y-axis, it is x square equals to 4ay is the parabola. Then the axis is what? This is the axis. What is axis? The straight line passing through the fixed point is called the axis. Here the axis is y-axis, x equals to 0. Now the same thing, if the parabola is downward parabola, for example, if the parabola is downward parabola, then x square equals to minus 4ay and the vertex is still a 0, 0 and the focus is here. This is our S and here this is 0, comma minus a, because this point lying on the negative y-axis. Therefore minus a, on y-axis x coordinate is 0. Here also x coordinates are equal. The parabola is symmetric about y-axis. Okay, now. So and still the axis is the y-axis, x equals to 0. And now, so this is my chord axis and this is origin. So origin here is 0, 0. So this origin has been shifted to a point without changing the direction of the coordinate axis. What I mean to say is, this line is parallel to y dash. Therefore this is capital Y dash. And this axis is parallel to x dash. This is capital X dash. Now for this 0, 0 is h comma k, because the origin is shifted to some other point which is other than origin. This is h comma k and this is 0, comma minus a. With 0 h will be added, with minus a k will be added. So 0, comma h comma minus a plus k. Here x coordinates are equal. It is parallel to symmetric about y-axis. Symmetric about y-axis, x power even. That too here h comma k. That means it is not x square equals to 4ay but x minus h whole square equals to negative. So minus 4a into y minus k. So this is all is required. Now solution, since the coordinates of otherwise since the x coordinates of the focus and vertex s comma a are equal, it is h. The x coordinates are equal. It is symmetric about y-axis. But here it is symmetric. It is parallel to y-axis. It is parallel to y-axis. Since it is parallel to y-axis, it is parallel to y-axis and the vertex is a point other than the origin and vertex is other than the origin, that is 1 comma minus 2. This is equals to h comma k. And so the distance between A and S is what? A. And A is equals to AS. AS is square root of 1 minus 1 whole square plus minus 7 plus 2 whole square. Minus 7 plus 2 whole square. This is equals to 5. A is equals to 5. And now this is 1 comma minus 7. Vertex 1 comma minus 2. So here this is A 1 comma minus 2, and this S is 1 comma minus 7. 1 comma minus 7 lies above or below? Obviously it is below. So here minus 1, minus 2, minus 3, minus 4, minus 5 is below. So this is 1 comma minus 7. Had it been above, so this is 1 minus 2, had it been 1 minus 1 above, then so symmetric about what? Here parallel to y-axis, x power even, that is x minus h whole square is equals to parallel to y-axis. Symmetric about y-axis is x power even, x square equals to 4ay or x square equals to minus 4ay. Here the vertex is other than origin, therefore it is x minus h whole square equals to minus 4a into y minus k. Why minus 4a? Because 1 comma minus 2 is above, therefore vertex is below the vertex. It's not like here, like this. The vertex is not here. Had it been here, then it would have been plus 4a into y minus k. Therefore this is cleared. This is still cleared. So now x minus, what is h comma k that is given? 1 and minus 2. So x minus 1 whole square is equals to minus 4, a is 5 into y minus, the value of k is minus 2. This is equals to x minus 1 whole square is equals to minus 20 into y plus 2. Now the sixth question is, find the equation of the parabola whose focus is S 3, 5 and vertex A 1, 3. Unlike the problem which we have discussed before, that is fifth problem, there x coordinates are equal. Then it is parallel. Then it is symmetric about y-axis. If y coordinates are equal, it is symmetric about x-axis. Symmetric about x-axis, y power even. So y square equals to 4ax. The vertex is other than the origin means y minus k whole square equals to 4a into x minus h and all. But here neither x coordinates are equal nor y coordinates are equal. Then actually if you remember, this is the ninth case of the topic various forms of a parabola. We have discussed various forms of a parabola, in which all the 8 cases we have discussed, and ninth case also we have discussed at the end. That is, the parabola is neither symmetric about x-axis nor y-axis. So the parabola will be like this. For example, the parabola is like this, which is whose axis is not symmetric about either x-axis or y-axis. Now the focus S is here, which is 3, 5, and the vertex is A 1, 3 here. So this equation of this parabola is what we are required to find out. So this is the vertex, this is the directrix. So this is Z, this is L equals to 0. Okay. So here Z, A, S are collinear points and A is the midpoint of ZS. These distances are equal. So let us take, let P x1 y1 be any point. Solution, let P x1 y1 be any point of the locus of the parabola. Now, so from this P, I will draw a perpendicular. This is suppose M. Let M be the projection or perpendicular projection of M be the projection of P on L equals to 0 on the directrix. So according to the definition of a conic, according to the definition of a conic, so its distance from a fixed point SP, the ratio of its, so SP is equals to PM. So now SP is equals to PM. So this distance is equals to this distance is what we have discussed for the condition for the parabola. Now, so SP is okay. SP we can find the distance formula. PM is the distance of a point P x1 y1 to this line. First of all, what is the equation of this line is what we need to find out. So this is what this line is a principal axis. What is meant by principal axis? The straight line passing through the fixed point which is focus. The straight line passing through the fixed point which is focus and perpendicular to the directrix is called the principal axis. Therefore, first of all, what is the equation of principal axis? Equation of principal axis passing through A comma S is, this is x1 y1, this is x2 y2. So y minus y1 equals to y2 minus y1 by x2 minus x1 into x minus x1. This implies y minus y1 is equals to y2 minus y1 5 minus 3 2 by x2 minus x1 3 minus 1 2 into x minus x1 x minus 1. 2 gets cancelled. Y minus 3 is equals to x minus 1. Therefore, the equation of axis is x minus y minus 1 plus 3 plus 2 equals to 0 plus 2 equals to 0. The slope of this point, the slope of x minus y plus 2 equals to 0 is m equals to minus a by b, minus a is x coefficient by b is y coefficient minus 1. So this is 1. Therefore, the slope of the directrix L equals to 0 is minus 1. L is perpendicular to the slope of this directrix is minus 1 we get. Okay, and so to find a equation of a line along with the slope, one point is also needed. So let us try to find out the value of Z. We all know that Z, A, S are the collinear points and A bisects ZS. That means A is the midpoint of ZS. Let ZB, I'll take this to be alpha comma beta. Let Z be alpha comma beta. That means A is the midpoint of SZ. That means 1 comma 3. This 1 comma 3 is equals to alpha plus 3 by 2 and beta plus 5 by 2. Then 1 is equals to alpha plus 3 by 2. From this, 2 is equals to alpha plus 3. Therefore, alpha is equals to 2 minus 3 minus 1. And 3 is equals to beta plus 5 by 2. So 2 3s are 6, beta plus 5. Therefore, beta is equals to 6 minus 5, which is 1. Therefore, alpha comma beta is equals to how much? Minus 1 comma 1. So therefore, this alpha comma beta is now minus 1 comma 1. Now, the equation of this L equals to 0 is, equation of L is having slope L, having m equals to slope m equals to minus 1, and passing through minus 1 comma 1 is y minus 1 equals to m is minus 1 into x minus of minus. Y minus 1 equals to m into m is minus 1 into x minus x1, x plus 1. So this is equals to minus x. If you transpose here, plus x plus y. So this is minus 1 gets cancelled, x plus y equals to 0. Therefore, this line is x plus y equals to 0. And from here onwards, what is PM? PM is the perpendicular distance of Px1 y1 to the line. So here PM is equals to what? PM is equals to perpendicular distance of P x1 y1 to this line x plus y equals to 0. That is PM equals to modulus of x1 plus y1 by square of the quotient of x plus square of the quotient of y. So root 2. Therefore, we have PM, the distance formula between S and P, root of x2 minus x1 whole square plus y2 minus y1 whole square. PM is this whole square. So if you square on both sides, we will get it. We will get the equation of the parabola. Therefore, equation of the parabola is SP is equals to PM. That means SP square is equals to PM square. So PM we got is x1 plus y1 by root 2. So SP square is distance formula, square root of. But SP square, if I do, square and root will be eliminated. So this is x1 minus 3 whole square plus y1 minus 5 whole square is equals to PM square x1 plus y1 by root 2 whole square. This is equals to root 2 whole square is 2. So 2 into x1 minus 3 whole square plus y1 minus 5 whole square is equals to, this is x1 plus y1 whole square. This is equals to 2 into x1 square plus 3 square 9, 2 3s are 6x1, a minus b whole square plus y1 square plus 5 square 25 minus 2 5s are 10 by 1 is equals to x1 square plus y1 square plus 2x1, x1 square plus y1 square plus 2x1 y1. Now this is equals to 2x1 square minus x1 square is x1 square plus 2y1 square minus y1 square is plus y1 square. Next, this is minus plus 2x1 y1 if you transpose here minus 2x1 y1. Next, this is minus 2 6 minus 12x1. This is minus 2 into 10 y1 minus 20 y1. Next, here 9 plus 25 is 34, 2 68 is equals to 0. Therefore, the locus of P x1 comma y1 is x square plus y square minus 2xy minus 12x minus 20y plus 68 equals to 0. You may ask, sir, it is not seem to be a parabola, but we have discussed in the explanation first video of this parabola the second degree non-homogeneous equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0 is a parabola if h square equals to ab. We have discussed it. So let us see whether h square equals to ab is satisfied with this or not. What is h here? H is equals to 2hxy. 2h is equals to minus 2, h is equals to minus 1. So a is equals to x square quotient is 1. So you compare x square quotient, ax square is 1x square, a is equals to 1, b is equals to by square. So b is equals to 1, 2hxy, so xy quotient is 2h. Here xy quotient is minus 2. That means 2 gets cancelled, h is equals to minus 1. So now h square equals to ab, yes, minus 1 whole square is equals to 1 into 1. So 1 square equals to 1. Therefore this condition is satisfied. Therefore the second degree non-homogeneous equation, this represents the parabola.